everyone, today we'll be looking at the cobalt complex with ammonia as a ligand. Our goal for this complex is to draw its valence bond theory diagram and its crystal field theory diagram. Before we start, we should figure out what type of shape this complex ion acquires. I have already drawn out the shape for the complex ion, which is an octahedral. This is a list I have written about what we know about this cobalt complex before drawing the valence bond theory diagram. The cobalt we are working on is cobalt 3+ because ammonia has a neutral charge. Cobalt 3+ has 6 electrons in the 3d orbital. This complex has a weak ligand, which is ammonia, and you can see that the complex has 6 ammonia attached to the cobalt 3+, which tells us that the coordination number is 6. We also know from the previous slide that the shape of this complex ion is an octahedral shape. An octahedral has 2 different hybridization for the valence bond theory. It has D2sp3 or it has sp3d2. The difference between them is that D2sp3 has an inner d orbital, whereas sp3d2 has an outer d orbital. To figure what hybridization works for this complex is that we have to draw the valence bond theory. As said previously, cobalt 3+ has 6 electrons in the 3d orbitals, and the complex ion has a weak field ligand. Weak field ligands do not cause a pairing energy. Strong field ligands, such as cyanide, causes a pairing energy. Pairing energy is when the electrons in the inner d orbital are paired and will have an excited state to hybridize to D2sp3. But because this complex ion has a weak field ligand, their hybridization will be sp3d2 and will start off in the ground state. Then it will hybridize straight into the bonded state. It will also have an outer d orbital. We have to box sp3d2 and show that this will hybridize. We should also state that this is an outer d orbital. Again, inner d orbital, outer d orbital. Now we are at the bonded state after hybridizing the sp3d2 orbitals in the ground state. Again, our hybridization is sp3d2. We need 6 available spots for the electrons, so the 6 ammonia ligands are able to attach to the cobalt 3+. Now we're going to draw our electrons in the sp3d2. And we have to show that there are 6 sigma ammonia bonds attached to these electrons. Cobalt 3+ is also D6 because there are 6 electrons in the 3d orbital. We are finally finished with the VBT diagram, but is this paramagnetic or diamagnetic? Well, diamagnetic is when the electrons are paired and does not have any lone electrons. Paramagnetic is when there are still lone electrons in the orbital. In this case, the magnetic property of this cobalt ion is paramagnetic. If it was paired with a strong field ligand, that will cause a pairing energy and it will be diamagnetic. This will be the setup for the crystal field diagram when the complex ion has the shape of an octahedral. The type of ligand also plays a huge role on how to draw in the electrons in the T2G level and the EG level. Since we have a weak field ligand, again ammonia, it will have a smaller crystal field split. So the electrons will be drawn out like this. Because we have this type of electron setup, we consider this as a high spin, which is caused by the weak field ligand ammonia. As you can see, the electrons drawn in the crystal field diagram should be the same in the valence bond theory diagram. The weak field ligand also causes this crystal field diagram to have a greater pairing energy than the crystal field splitting energy.